In this video, we'll take a look at section 6.2, which is rational numbers as exponents. In other words, what this is saying is we're going to have fractions as exponents. And in this section, we'll take a look at how to simplify those problems. So our first objective, we're going to write expressions with or without rational exponents. Now we have this property, a raised to the 1 over n. This is equal to the nth root of a. Let's take a look at some terminology. So we saw in the last section, that symbol is called the radical sign. The number inside of your radical sign, or the expression underneath your radical sign, this is called the radicand. And now this n, this is called the index. So the bottom number in the fraction, the denominator of the fraction, this is your index of your radical. Let's take a look at an example. So rewrite without rational exponents and simplify if possible. So we have y raised to the 1/4 power, because we have our radical sign, and now our radicand is y, and our index is the denominator of the fraction. So this would be the 4th root of y. Now 4th root of y, we cannot simplify it. For example, if we had, say, 4th root of y to the 4th, this is something that we could actually simplify. This would become absolute value of y. But since it's just y to the 1st, we cannot simplify that. Let's take a look at another example. So rewrite without rational exponents and simplify if possible. So we have 3a raised to the 1/2 power. So now it's our whole 3a, the whole expression 3a is being raised to the 1/2. So underneath the radical sign, our radicand is going to be 3a, and our index is 2. Now, whenever your index is 2, this is really just saying the square root. So traditionally, you don't see that there. So this is just the square root of 3a. Next example, so 16 raised to the 1/4 power. So our radicand is 16, and our index is 4. So what we really have is the 4th root of 16. So what we're trying to find here is a number raised to the 4th power that gives us 16, which is actually a whole number. We have 2. So this is because 2 raised to the 4th power, this gives us 16. So we can actually simplify the 4th root of 16. Take a look at another one. So we have 125 raised to the 1/3 power. Okay, so our radicand is 125, and our index here is 3. So we have the cubed root of 125. This is a radical that we can actually simplify. So cubed root of 125, this is equal to 5. And this is because 5 raised to the 3rd power gives us 125. Now let's go the other way around. So we have the cubed root of 19ab. We want to rewrite it with rational exponents. So our radicand is 19ab. We're going to have to put this in parentheses because this is what was our radicand. This was the whole expression underneath the radical sign. And this would be raised to the 1/3 power. So our index is 3. So 3 is supposed to be in the denominator of our fraction. Let's take a look at another one. This time we have the 5th root of x squared y divided by 16. So we're going to rewrite this so we have a fraction as an exponent. So our radicand here is x squared y over 16. And now this will be raised to the 1/5 power. So it'll be raised to the 1/5 power. So notice our index is the denominator of our fraction. Okay, next example, rewrite with rational exponents. We have 19 times the cubed root of ab. Now notice the 19 is on the outside of the radical sign. So this isn't going to be raised to a power. So we'll have, let me just rewrite the problem. So we have 19 times the cubed root of ab. this would be equal to 19 times. Now our radicand, the expression underneath the radical sign is AB. This would be raised to the 1/3 power. So this would be 19 times AB raised to the 1/3 power. Okay, now we have another property. So all of those rational exponents that we saw, the numerator was 1. Now let's take a look at what happens if it was some other number besides 1. So if you have a raised to the m over n, this is equal to the nth root of a raised to the mth power. Or another way that we could rewrite this is the nth root of a, and this whole expression raised to the mth power. Okay. So the numerator of your fraction, this is what you're raising your radicand to, and the denominator is your index. Let's take a look at some examples. So we have x raised to the 3/5 power. So we have our radical sign. Our radicand is x. Okay. And now the denominator is our index. So we have the 5th root of, and now we have to raise our radicand to the 3rd power. So this would be the 5th root of x cubed. And for this particular radical expression, we cannot simplify it. So if it was, say, x to the 5th, the 5th root of x to the 5th, this would just become x. But since it's just raised to the 3rd power, since it's just x to the 3rd power, this cannot be simplified. Let's take a look at another one. We have 8 raised to the 2/3 power. Okay, so this is equal to, so remember the denominators are index, so this is really cubed root of 8 raised to the 2nd power. Now let's check and see if we could simplify this. So this would become the cubed root, and now 8 raised to the 2nd power gives us 64. Cubed root of 64 is actually equal to 4, because 4 raised to the 3rd power gives us 64. Now another way that we could rewrite it, remember there was 2 forms for our property. We have 8 raised to the 2/3 power. We could rewrite it as the cubed root of 8 and then raised to the 2nd power. So now cubed root of 8, we can actually simplify this. This is equal to 2, because 2 raised to the 3rd power gives me 8. So now we have 2 raised to the 2nd power, which gives me 4. So either way that you write it, you'll still get the same result. Now let's go the other way around. We want to rewrite with rational exponents. So we have the cubed root of 7abc, and this whole thing raised to the 4th power. So we have 7abc, and we're putting this in parentheses because it's this whole expression that's underneath the radical sign. And remember, we're going to have it raised to some fraction. Well, remember the index, which is 3, this is the denominator, and whatever we're raising that to is the numerator. So this is really the same thing as 7abc raised to the 4/3 power. Let's take a look at another one. So rewrite with rational exponents. So we have the 5th root, 6 raised to the 7th power. Okay, so our radicand here is 6. So we're going to have 6 raised to the, now remember, the index is the denominator. And whatever we're raising the radicand to, this is the numerator of the fraction. So this is really 6 raised to the 7/5 power. Now we have another property when we have negative exponents. And what this states is if we have a raised to the negative m over n, this is equal to 1 over a raised to the m over n. So essentially what we're doing here, so if we have a raised to the negative m over n, I'm going to put this as over 1. You take the reciprocal, and then you change the exponent to be positive. Let's take a look at an example. So we have 16 raised to the negative 1/4 power. Let's go ahead and simplify this. Now, since I have a negative exponent, I have to take the reciprocal of 16. Remember, this is really, it's like 16 over 1. So reciprocal of 16 over 1 would be 1 over 16. And now I change the exponent to be positive. Well, now we can still simplify this. This would be 1 over. Now 16 raised to the 1/4 power. Remember, the denominator of the fraction is your index. And now we have 16 inside that radical sign. So what we really have is the 4th root of 16. Now we have 1 over, and now the 4th root of 16, we saw this earlier, this is just equal to 2. So 16 raised to the negative 1/4 power is the same as 1 over 2. Let's take a look at another one. So we have 3xy raised to the negative 7/8. Okay, well, let's go ahead and take the reciprocal. So we have 1 over 3xy. And now we change our exponent to be positive. So this would be 1 over 3xy raised to the 7/8 power. Let's take a look at another problem. So rewrite with positive exponents and simplify if possible. So we have 7p raised to the 3/4 times q raised to the negative 6 over 5. Now the only variable here, the only part that's being raised to a negative exponent is the q. So this is the only part that we have to actually take the reciprocal of. So we have 7p to the 3/4 times, let me write it this way first, 1 over q raised to the 6 over 5. So since q is raised to the negative exponent, I had to take the reciprocal of q, which is 1 over q, and then I changed the exponent to be positive. And now I could simplify this even further. This would become 7p to the 3/4 over q raised to the 6/5. And this would be my final answer. Another example. So we have 11m over 7n raised to the negative 2/3. So now we have this whole fraction being raised to a negative exponent. So all we have to do here is go ahead, flip the fraction, take the reciprocal of it. So this becomes 7n over 11m. And we change the exponent to be positive. So it'll be raised to the 2/3 power. Now our next objective, this is the laws of exponents. Now our first law, take a look at our first one, a raised to the mth power times a raised to the nth power. So we saw a little bit of this in a review in a previous section. This will become a raised to the m plus n. So when you have the same base and you're multiplying, all you have to do is add the exponents with each other. Another property, if you have a raised to the m, and that whole expression raised to the nth power, in this case you multiply your exponents. This becomes a raised to the m times n. Now if you're dividing and you have the same base, so a raised to the mth power divided by a raised to the nth, this becomes a raised to the m minus n. You subtract your exponents. If you have ab raised to the mth power, you raise a to the mth power and b to the mth power. If you have a fraction, a over b raised to the mth power, raise the numerator to the mth power and raise the denominator to the mth power as well. Let's take a look at examples. So use the laws of exponents to simplify. So we have 7 raised to the 1/3 power times 7 raised to the 3/5 power. So we have the same base. So in order to simplify this problem, we keep the base the same, and now we add our exponents. So this would become 1/3 plus 3/5. Okay, so we have to add these two fractions with each other. But be careful, whenever you're adding or subtracting fractions, you have to have the same denominator. So we need an LCD. So the smallest number that 3 and 5 can both go into is 15. So we have to change each one of these fractions so the denominator is 15. So for the 3, I have to multiply it by 5 to get 15. So I have to multiply the numerator by 5 as well. So that gives me 5 over 15. Our next fraction, so 3 over 5, I have to multiply 5 by 3 to get 15. So that means I have to multiply the top by 3 as well. So 3 times 3 gives me 9. Now that I have the same denominator, I can add these fractions with each other. This becomes 7 raised to the 5 plus 9 gives us 14 over 15. Let's take a look at another one. We have 5 raised to the 7 6 divided by 5 raised to the 5 6. Okay. So I have the same base, and now since I'm dividing, I go ahead and subtract my exponents from each other. So I have 7 over 6 minus 5 over 6. Now this one's a little bit easier because I already have the same denominator. So I could actually subtract these fractions. So I have 5 raised to the now 7 minus 5 gives me 2. I keep the denominator the same, so I have 2 over 6. Now one last thing, 2 over 6, I could actually simplify it. This becomes 1 over 3. So I have 5 raised to the 1/3 power. Let's take a look at another example. So we have 9 raised to the 3/5 raised to the 2/3. So I have 9 raised to the 3/5 and then raised to the 2/3. Well, my laws of exponents tell me to multiply my exponents. So I have 3 over 5 times 2 over 3. Now when you're multiplying fractions with each other, you don't need the same denominator. What you could do is just go ahead and multiply straight across. So I have 3 times 2. So I have 9 raised to the 3 times 2, which gives me 6 over 5 times 3, which gives me 15. But now be careful because this is a fraction we can actually simplify. So 6 over 15, a number that goes into both 6 and 15 is 3. 3 goes into 6 twice, it goes into 15 5 times. So this is 9 raised to the 2/5. Okay, let's take a look at another problem. This one a little bit more difficult. So we have p raised to the negative 2/3, q raised to the 1/4, and this whole thing is raised to the 1/2. Well, my laws of exponents tell me to raise each one of these to the 1/2 power. So I have p raised to the negative 2/3 raised to the 1/2 times q raised to the 1/4 raised to the 1/2. Now I could use my other law of exponents, where now it tells me to multiply my exponents with each other. So I have p raised to the negative 2/3 times 1/2 q raised to the 1/4 times 1/2. Now let's go ahead and multiply the fractions with each other. So we have p raised to the, so negative 2 times 1, I get negative 2 over 3 times 2, which gives me 6. I have q raised to the, so 1 times 1 gives me 1, 4 times 2 gives me 8. Okay, we're not quite finished yet, so I have that fraction I could simplify. So the negative 2 over 6 gives me negative 1 over 3. And I have q raised to the 1 over 8. But we're still not quite finished yet. Since I have this negative exponent, technically my problem is not completely simplified. So whenever you have a negative exponent, you have to flip it. So we'd have q raised to the 1 over 8 all over p raised to the 1/3. And now my answer is completely simplified. All my fractions are simplified, and I don't have any negative exponents. So that was it for section 6.2. If you have any questions, remember, don't hesitate, just email me and I'll help you out.